So we are on the fifth lesson, and we are requested to, or we intend to start looking at our new topic, and this is the topic of Hooke's law, which is our sixth topic in Form 2. And I believe that when we talk about Hooke's law, we are talking about the applications of the springs. Because when you are looking at Hooke's law, you look at about the issues of the springs and the elastic materials. I tend to believe that we have seen a spring, and what happens to a spring is that a spring is one material that you can stretch it can extend. If you release it comes back to its original position. When you look at, for example, a bladder, that elastic material bladder, you can stretch it extends, then you release it comes back to its original position. So in this topic, we are majorly going to discuss more of the springs and more of the elastic materials. And I believe in our daily life, or as we stay in this world, we have been able to look at so many areas where the springs are being applied. And I think one of the areas that we have seen is, for example, the shock absorbers in the vehicles. The vehicles have those shock absorbers because of the springs. We also have the clock. If you look at a clock, as the clock works, it is the presence of the springs there. There is an application of the springs. We have the issues of the safari beds. Safari bed, if you jump on it, it springs you up and down. Okay? It is because of the presence of the springs. So that tells us that in our daily life, we cannot do away with the springs. Springs are very important, and that's why we want to discuss it in Hooke's law. So the purpose of this lesson today, we want to verify on Hooke's law. We want to look at an experiment, and the aim of the experiment is to verify on talking about Hooke's law. To verify Hooke's law. To verify Hooke's law. And in the verification of Hooke's law, we shall find some apparatus which I think I've provided with you there in the worksheets. You may require the screen, you require a stand, you require a meter rule, and you require the masses. So as we are going to do it, I've given you a sheet which you will follow to carry out the process of Hooke's law. And what I require us to do, we are going to follow that procedure that we have given you that worksheet. You carry out the process of Hooke's law. You are supposed to fill in that table what happens when you put, maybe possibly, as one of the stand like this one here. This is our screen. We are supposed to partially be able to ascertain if I get a screen like this one here, I hang it here. What do you expect will happen? It will definitely stretch. So if I put it like that, the screen is supposed to stretch. So what we want to establish from here is that what happens when you add more screens? What will happen to the extension? And that's what we want us to learn in that experiment. You will feed that table, you will be adding some masses and be able to see what happens to the extension as the masses increase. So that's what we want us to do in the next 30 minutes and get the data. So in our groups of around 4, they will be seated. You have the worksheet here. So I want you to follow this worksheet and write your data in that worksheet. Then the next time, shortest time possible, I want us to see in each group which data are important and how we are going to look at it so that we can get the statement of Hooke's law. So in our groups, faster, I want us to follow that procedure and be able to establish the experiment on Hooke's law. So we can get started. Each member is participating. I want to see that each member is actively participating. And according to the worksheet, you should be able to identify the initial position of the pointer. So be able to identify the initial position of the pointer and follow the worksheet. So I'm seeing most of the groups are already done. There's only one group which is finalizing, but there's only one group which is finalizing. The other ones are already done. So I think it is important that we now look at now what we have recorded. Can each group present the worksheet? Can each group now present the worksheet? I think this group is already done. That is okay. That we can get seated. Group 2. Yeah. The table is okay. Group 3. The table is okay. I think we can use this data to establish what we have here. So if you look at the table here, you are supposed to identify the initial position of the pointer, which was in centimeters. Then you are given the mass, and you are given the force in newtons, mass in grams, force in newtons. You are given extension in centimeters, then extension in meters. So from here, you are given the masses 50 grams, you have 100 grams, you have 150 grams, and you have 200 grams. So according to the worksheet, you are supposed first to complete. You are supposed to complete this part of the force in newtons. And I think based on group 1, they have done it very well. Each group has already presented the values, whereby the answer here is 0.5. This one is 1.0, 1.5, and this is 2.0. I think that is quite okay for each group. The data is okay. Then you are supposed to identify the initial position of the pointer, which I think each group has its own data, which is okay. Then we have the extension that was obtained for each group. And the extension, I think each group has given the data. And on the look of things, I don't know about this one, we can establish to use the data from group 1. The extension here was 6.0, 8.0, 9.0, 10.0. That is in centimeter. In meter, 0.6, 0.06, 0.08, 0.09, and 0.10. Now, based on the data we have gotten there, what can you say about the relationship between increase in the force? As the force increases, what happens to the extension? Yes? The force or the extension also increases. I think that's a very good observation. As the force increases, the extension also increases. And that one you can easily see from here. Just get me this letter. So if, just do like that, if you have a mass, the way you head it, if we place this mass here, the way you placed it, if I place the first 50 gram mass, you can see it's extending. If I get another mass and attach it here, you can also realize that, again, the spring is extending. So that is that as you increase the mass, what happens to the extension? Extension also increases. And that is important to identify that. Now, based on that, if we are now supposed to sketch the graph the way we have sketched from the worksheet, and if I look at the three groups, each group has, if they have plotted a graph of force in newtons against extension in meters, and looking at each group, the worksheet for each group, there is a behavior I'm seeing here. The graph they are getting is a linear graph, which is a straight line starting from the origin. So that tells us that as the force increases, what happens to the extension? The extension also increases. And that one brings us to a conclusion or a summary of Hooke's law, which we now need to state or give a statement of Hooke's law. And I want us to put it down like this. So, what does the Hooke's law state? So, we say that Hooke's law states that for a helical spring, or any other elastic material, force is directly proportional to the extension. Provided elastic limit is not exceeded. Force is directly proportional to extension, provided elastic limit is not exceeded. So that now brings us to a summary of Hooke's law, which was the intention of our lesson, because our objective was to verify Hooke's law. And I think we are able to do the practical, and we are able to establish the relationship between the force and extension, and we are able to plot a graph and see how force and extension are related. So from there, we were now able to establish that is now the statement of Hooke's law. Now another part that we are now supposed to look at it is now, how do we determine the gradient of this graph? In mathematics, how do we normally get gradient? Yes, somebody? Yes, Katiwa? Yeah, the change of what is the y-axis. So we normally say that the gradient is change of what's in the y-axis, and what's in the y-axis here? It is the force. So it is changing the force over the change of what's in the x-axis, which for this case is the extension. So basically, assuming this is the data, if I'm going to use the data for group 1, assuming this one was now 1, and this one maybe was 2, this one was 3, and this one is maybe 4. So quickly we can look at, we pick 2 points which are in line. So when we pick these 2 points, we draw a straight dotted line like this one here. We get the coordinates of this point. And the coordinates for this point, the x coordinate becomes 1, and the y coordinate is 2. Then for this point, the x coordinate is 3, the y coordinate is 4. So we look at now the change in y over the change in x. So look at what is the y-axis now. So the y coordinates are 4 and 2, so it becomes now 4 minus 2 over 3 minus 1. So what does it give us now? It gives us 2 over 2. So that one transfers what? 1. That one transfers 1. Now this gradient must have the SI units. So how do we derive the SI unit? We look at what is the SI unit of force? Newtons. What are the SIs of extension? Yes, money. It is in meters. So from there, we can easily derive the SI units of the quantity we are using here. So from that, the SI becomes what? Newtons per meter. So from there, we get the SI units newtons per meter. So that's how we end up getting the gradient. And this gradient that we get here stands for a given physical quantity in physics. And that physical quantity is called spring constant. The physical quantity is called what? The spring constant. So the gradient of force against extension gives you a physical quantity known as the spring constant. And that spring constant has an SI unit of newtons per meter. So the SI of spring constant, at the end of the day, we say there are newtons per meter. So I think the topic or the subtopic for today has assisted us. One is to verify the Hooke's law. Then from there, we have already done the practical. We are able to plot the graph and we are able to tell the gradient of the graph. And from there, we are able to tell what does the physical or what does the gradient of that graph stand for. Which we have identified it stands for one physical quantity known as the spherical constant. So for today, I think that is well done. So what I will do for you today is that I'm going to leave you with an assignment from exercise 3.1 in your textbook. Exercise 3.1 in the textbook. You are given a table. So you are supposed to plot a graph. Then use the graph to determine the slope or the gradient. Then you are supposed to identify what does that physical quantity for the gradient stand for. And I believe you'll be able to do that. You will have attained the objective of the topic completely. Think that's okay? This lesson, unless somebody has a question. So, having no question, I think we shall continue from there in our next class. Thank you.